Right, this lesson, we are looking into the last bit about parametric equation, which is the modeling part. So modeling is all about the variables, knowing the variables. How many variables are there, and what does each variable mean, and also which ones are constant. Then the next thing is, once you know your variables, once you know your what each variable means, then it's about linking the information given to you by the question to the variables that you've got. Okay, so let's have a look in here. Example, a plane's position at time t seconds after takeoff can be modeled by the following parametric equations. X equals v cos theta times t meters, y equals v sine theta t, m is meters, m is not m is just unit, where v is the speed, theta is the angle of elevation, and x is the horizontal distance, and y is the vertical distance relative to a fixed origin. So first question is, how many variables are there in this question? So I'll give you time to think. 3, 2, 1. There are, so x is variable, okay, y is variable, so that's 2. V is not a variable because v is the speed of the plane, and theta is also not a variable. So in this question, and t is a variable. So in this question, the variables are x, y, and t. Okay, as usual in a parametric equation, you can imagine x, y is the position, think of it, and t is usually time. So these three are usually variables. The rest of them tend to be constants. Okay, so there's a little trick for you. If you want to write down, you write down. Okay, I'll say again, x, y, and t tend to be the variable, and the rest of them are constants. It's not 100% always true, but this usually works for parametric equation. Just a rule of thumb. So in here, when a plane has traveled 600 meters horizontally, so it's all about linking this to our variables. So we know x, y, and t are the variables. Okay, x, y, and t. 600 meters, that's clearly x, and 120 meters, that's clearly y. Calculate angle of elevation theta. Well, it's nice that actually they gave you a little diagram, so we can use this because we can know that's the right angle. So question A, as weird as it sounds, it has nothing to do with modeling. It's more about the tan theta trigonometry. Tan theta equals y over x. So theta equals inverse tan of 120 over 600. And if you plug in the calculator, that will give you theta equals 11.3 degrees, right? So that theta value is going to stay constant, right? So next part, given that the plane's speed is 50, so linking this to variables or to any of the constants in here. So speed, okay, speed is matching, okay. Then we know this is 50. Okay, so we know v is 50. So find a parametric equation for the plane's motion. So when we find a parametric equation, so part B, so we know x equal v cos theta times t. So we know v is 50. So 50 cos theta 11.3 times t. So put in a calculator, I've got 49t. And then for y equal v sine theta times t. So v is 50 sine theta 11.3 times t. So y equal, put in a calculator, 9.81t. And it all makes sense because, as I said, the variables are x, y, and t. So we have singled down just the two parametric equation, a pair of parametric equations with x, y, and t being the variables. T is technically not a variable. It's technically speaking, it's called perimeter. Anyway, so part C, find a vertical height. Okay, so find a vertical height. So which variable are we finding? The y. So after 10 seconds, that's t. So part C, to find y given t, so when t equals 10, if I want to find y, I use the y equation. 9.81 times 10, that's 98.1 meters. Nice and easy. Part D, show that the plane's motion is a straight line. So I'll give you time to think, pause the video, think about straight line. So what kind of math concept are they bringing out from this question? Are they trying to get to? How can you prove something a straight line? Okay, pause the video and play the video now. The straight line means y equals mx plus c. So in other words, if you want to show as a straight line, to show a straight line, we need to bring it to the form of y equals mx plus c. In other words, this is a Cartesian. So what the question is trying to ask you to do is to change the parametric equation into Cartesian equation. Well, we can do that because we've learned that in the previous chapter. So x equals 49t and y equals 9.81t. We can easily do that, can't we? So to make t a subject in here, x over 49 equals t sub into y. So we then have y equals 9.81 times x over 49, which you get 0.2x. So not 9.81 divided by 49 is 0.2. So this is a straight line, okay? And therefore it's a straight line because you can see y equals mx plus c. C is just 0. So it's a straight line, right? So you can see they're asking you to do Cartesian without asking you to do the Cartesian, okay, directly. So part E, explain why the domain of t where t is greater than 0 is not realistic. So domain of t as with the domain of t is not asking about the x value, it's about the t value itself, okay? The domain of t greater than 0 is not realistic. The domain of t is t greater than 0. So they're asking you why t greater than 0 is not realistic. Well, you have seen similar modeling question where they ask you why is it not realistic. The trick I can tell you is think about in the long term, okay? If t gets a very big value, what will happen to x and y? Okay, so if t gets really large, then if t gets very large, let's say in here, so we look at the Cartesian, the parametric equation again. If t gets very large, what happens to x value? If t gets very big, so as the x value. If t gets very big, so as the y value. So what does x and y stand for? The horizontal and vertical distance traveled. That means they keep climbing the x value. That means you've traveled horizontally very, very far. And y means very, very high. That means you go into outer space and say goodbye to your parents and say goodbye to McDonald's because you're not going to see them again when you've flown into outer space. So part E. So not realistic because as t increases, so do the horizontal and vertical distances. The plane cannot climb forever. Okay, so that's why it's not realistic. Okay, you cannot go up and up and up forever. All right. So yeah, so that's not realistic. Think about long run, right? All right. So what's wrong? Think about long run always. It works for exponential modeling, works for straight line modeling, works for quadratic modeling, works for trigonometry modeling. Think about them. Okay, long run. What happens in the long term? Right. So next one, example. So we have a next example where we look at the motion of a figure skater relative to a fixed point, fixed origin O at time t minutes, so t as a unit minutes, is modeled using the parametric equations. So these are the equations, t is greater than or equal to 0, where x and y are measured in meters. Find the coordinates, so coordinates means xy, you want to find xy, of the figure skater at the beginning of its motion. So what are the variables in here? Let me answer you. X, Y, and t. If I want to find x and y, then surely I must know t. Otherwise, it's impossible. So t, beginning of motion. So how do you relate this to beginning of motion? With t equals 0. So part A, without further ado, when t equals 0, then x equals 8 cos 20 times 0. So x equals, so 8 cos 0 is 8. Is 1, I mean cos 0 is 1, 8 times 1 is 1. 8 times 1 is 8, sorry. That's why I'm saying mental maths is dangerous. Do not trust your brain on the mental maths, okay? It's trying to trick you to a wrong answer. So it's like a spy. Y equals 12 sine 10 times 0 minus pi over 3. Plug it in a calculator. It will give you a negative 6 root 3. Several coordinates, the starting coordinates is 8 negative 6 root 3. So if we find it out in the diagram, now a lot of people would have thought we're going to start right in the middle where the two eights, the two parts join, but that's not quite right. So 8 negative 6 root 3 means 8 negative 6 root 3. That means we start from here, roughly. So that's our starting point. Okay, so that's our starting point. Right. Part B, find the coordinates of the point where the figure skater intersects its own path. Now, this is not usually the type of question you'll be asked in a question in the exam, because this needs you to read the diagram to see where it crosses. You can see it crosses at it just needs you to look at the diagram. You see where it passes through, where it crosses its own path is here. It's -4, 0. So part B, as weird as it says, we're going to say -4, 0. How do we get that? Well, we say from diagram. Okay, right. So that's it. Let's leave it like this. Part C, find the coordinates of the points where the path of the figure skater crosses the y-axis. Cross the y-axis. What are you thinking? Yes, x equals 0. So cross the y-axis, x equals 0. Find the coordinates, so x and y again. If I know x equals 0, that means my coordinate is 0 something. So my thing is to make x equal 0 and see how it goes from there. So when x equals 0, I need to use the x equation. So x equals 8 cos 20t, divide 8 over 0. So 0 equals 8 cos 20t, divide by 8 cos 20t equals 0. Inverse cos of 0, arc cos of 0. Inverse cos of 0 is 1. Is it? No, so inverse cos of 0 using radians is power over 2. Now, there's one answer, but I can, judging by the diagram, I see it crosses the x at the y-axis 1, 2, 3, 4, 4 times. 4 times, 4 answers. Okay, so power over 2. Next time it crosses the 0 is power over 2 or 3 power over 2. So 3 power over 2. I need 2 more because there are 4 intersection points. I add 2 pi to both of these answers. Then I will get 5 pi over 2 and 7 pi over 2. Now you need to find more answers as soon as you do inverse cos. You do not find more answers until the end. You find it as soon as you arc cos, arc sine, arc tan, inverse sine, inverse cos, inverse tan. Some people do not like me saying arc cos, arc sine. Therefore I keep saying inverse, 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 but you get what I mean. Right. So I'll explain again. Why do we need 4 answers? 4 answers, because 4 intersection points on the y-axis. Okay, so yeah, right. So then I need to find t, divide everything by 20, do pi over 40, 3 pi over 40, and then 5 pi over 40, and 7 pi over 40. You can simplify the 5 pi over 40 if you want to, which is pi over 8. But anyway, who cares? Right, that's it. Oh wait, hang on, are we done? Not quite. Let's read the question again. Find the coordinates. I found t, but I haven't found the coordinates. So I need to find y value. To find the coordinates, y value, you need to use the y equation. Sorry, I keep mumbling quite fast today because I don't know. I'm excited with the figure skater. You know, it's about speed, isn't it? When you do figure skating, and also about elegance. And when I do the maths in here, it's so elegantly with all the steps and speed. You know, I'm feeling I'm doing a maths figure skater. Right. Right, so then next one is find the coordinates of y is the y equation. So y equal, let me write that, 12 sine 10t minus pi over 3. So then we'll sub in 1 by 1. When t equals pi over 40, sub in, okay? Y equal, just sub in the t value. You should get minus 3.11. And therefore the coordinate is 0, negative 3.11. The question didn't say, but 3SF, we'll just put it 3SF for now. When t equals, next one, 3 pi over 40, y equals 11.6. So the coordinate is 0, 11.6. And then when t equals 5 pi over 40, y equals 3.11. And last but not least, when t equals 7 pi over 40, y equals negative 11.6. That's still negative 11.6. All right, so I feel like I'm writing an essay. Obviously, with my elegant handwriting, it's a masterpiece. So these are 4 answers. Part D. Part D, let's read. Determine how long it takes the figure skater to complete one complete figure of 8 motion. Determine how long it takes the figure skater to complete one complete figure of 8 motion. Right. Which variable are they asking for? Which variable are they asking? Remember the variables x, y, and t. They're asking for how long. That means t is unknown. If t is unknown, then surely x and y are known, right? Question is, what's x and y then? How, when they complete one, when they return, when the figure skater return to its own motion, what do we know about x and y? Pause the video, have a think about. When you're ready to answer, you can press play. The answer is, it returns to the original position. That means x and y are back to the original, which is 8 minus 6 root 3. So I'll put it in here. So part D, okay, return to starting point means x equals 8 and y equals negative 6 root 3. So we'll do both of them. So when x equals 8, I've got 8. Sorry, hang on. X equals 8 cos 20t. So 8 equals 8 cos 20t. On the other hand, okay, it's like I've got a split personality. I can't just focus on my x, I have to focus on my y as well. So y equals negative 6 root 3. So y equals, what's the y equation again? 12 sine 10t minus pi over 3. Sub in y, negative 6 root 3 equals 12 sine 10t minus pi over 3. It's like we are in McDonald's, we have our burger and our fries. I don't know which one to eat first. Well, let's do the x first. It's like I've got two of these two equations. Which one should I do first? Or should I get my apple pie first? Too many decisions. But let's do it one by one. Okay, so 8 equals 8 cos 20t divided by 8 over is 1. Silly mistake. Can you guess what student will make in this line from here to here? The silly mistake student will make is they will put 0 on the left hand side because they thought 8 divided by 8 is 0, which is incorrect. Okay. Anyway, so let me put this on the left hand side. So 20t equals cos, so inverse cos of 1. Inverse cos of 1, put it in a calculator, it will give you 0. So 20t equals 0. And the other answer, so when does cos is 1? The next time is at 2 pi. Next one, 4 pi. Okay, next one, 6 pi. I don't know why I keep working out, but just in case, you know. So yeah. So t divided by 20, 0, pi over 10, pi over 5, and 3 pi divided by 2, 3 pi over 10. Right? Which is the answer? We don't know. So let's dive into the French fries. Let's dive into the other equation. Divide 12 over, so they give you negative root 3 over 2 equals sine 10t minus pi over 3. So then we inverse sine, so 10t minus pi over 3. If you inverse sine of negative root 3 over 2, so inverse sine of negative root 3 over 2, you get negative pi over 3. So negative pi over 3 is not an answer because we can't have negative. But anyway, negative pi over 3 means here. So the other answer of a sine to be negative is here. So if we go in that direction, this answer will be pi plus pi over 3. This answer will be 2 pi minus pi over 3. So that's 4 pi over 3. And that's 5 pi over 3. So I can now safely write minus pi over 3, 4 pi over 3, or 5 pi over 3. Once I found my first two answers, as in here, the principal solutions, I add 2 pi to find more. So 4 pi over 3 plus 2 pi. Why do I need to find 2 more? Well, actually, I don't have to. I don't know why. I just leave it like this first. So all I do next is, sometimes the board does a weird thing. It just gives a square bracket out of nowhere. There we go. Okay, there we go. It's gone. Right. What's next? We have to add pi over 3 to the right hand side and then divide by 10. right? So minus pi over 3 plus pi over 3 is 0. 0 divided by 10 is 0. Okay. And the next one, 4 pi over 3. So 4 pi over 3 plus pi over 3 divided by 10 is pi over 6. And then 5 pi over 3 plus pi over 3 divided by 10 is pi over 5. So which one is the answer then? Okay, so now let's look at it together. Okay. So in terms of x, the figure skater returns to the same x position, means in this line, when t is 0, pi over 5, pi over 10, pi over 5, and 3 pi over 10. The figure skater returns to the same y position that way, okay, at 0 and pi over 6 and pi over 5. So 0 appears in both, and so is pi over 5, but we know 0 is not the answer because when t is 0, that's where the figure skater was originally. So we know t is 0 is not. Therefore, when it returns to its own position again, return means pi over 5. So therefore, okay, takes pi over 5 seconds to complete. So power 5, if you don't like power 5, was there any reason? Maybe you are a, what's it? Never mind. What's the, when you discriminate numbers, is there a term for it? Maybe you'll be put in jail if you discriminate numbers at one point, maybe some years later. Anyway, 0.628 seconds. Let's pick 0.628 seconds. Minutes. I was thinking 0.628 seconds. That's way too fast. Travel faster than light. 0.628. Right. So 0.628 minutes to complete. And that's the end of the modeling. And that's the end of the parametric equation. Next time when we see this topic again, it will be differentiation, and then it will do a cameo again in integration. So that's the end of chapter 8, pure maths.